Inside the world's largest factories, a silent revolution is taking flight. Picture a space the size of 100 football fields, filled with towering machinery and complex assembly lines. How do you ensure every single part, every weld, every component is perfect? For decades, the answer involved teams of human inspectors and fixed cameras. But as our factories have become bigger, faster, and more complex, these methods are hitting their limits. What if I told you the future of quality control isn't a person with a clipboard or a camera bolted to a wall? What if it's a swarm of tiny, intelligent, flying robots? Welcome to Process Protocoll. Today, we are exploring the incredible rise of Robo-Bees, autonomous micro-drones that are completely transforming how we ensure perfection in manufacturing. These aren't just toys. They are sophisticated inspectors, equipped with advanced AI and high-resolution sensors, working together in a coordinated swarm. They can navigate the most cluttered factory floors, reach areas too dangerous or difficult for humans, and spot defects smaller than a grain of sand. This is not science fiction. It's the next step in industrial evolution, and it's happening right now. So, what exactly is a Robo-Bee? Imagine a drone small enough to fit in the palm of your hand, but packed with technology. It has multiple cameras, LiDAR sensors for mapping its environment, and a powerful onboard computer. But its true power isn't in a single drone, it's in the swarm. Using a concept called swarm intelligence, inspired by real bees and ants, hundreds of these drones can work together as a single coordinated entity. They communicate with each other, dividing up the inspection area and sharing data in real time to create a complete, high-definition digital twin of the factory floor. Let's break down how this works. At the start of a shift, a central command system releases the swarm. Each drone is assigned a specific zone. One might be tasked with inspecting the welds on a massive turbine blade, while another scans the circuitry of 1,000 microchips on a panel. They fly autonomously, using their sensors to avoid obstacles like robotic arms, moving conveyor belts, and other drones. Their cameras capture thousands of images per second, streaming this visual data back to a central AI. This is where the magic really happens. The AI acts as the brain of the operation. It analyzes the incoming flood of images, comparing them against a perfect digital model of the product. It's trained to detect the tiniest imperfections, a microscopic crack in a metal chassis, a slight discoloration in a chemical mixture, or a misaligned component that a human eye would easily miss. If a defect is found, the system instantly flags it, pinpointing its exact location on a 3D map. It can then alert a human supervisor or even direct a repair robot to the problem area. To understand why Robo-Bees are so revolutionary, we need to look at the limitations of traditional quality control. Human inspection, while valuable, is slow, subjective, and prone to fatigue. You can task a person to stare at metal seams for 8 hours straight without their focus eventually wavering. Fixed cameras are better, but they only see what's directly in front of them. They can inspect the underside of a vehicle chassis or the inside of a complex engine assembly without massive, costly reconfigurations of the production line. This creates blind spots where defects can slip through unnoticed. Robo-Bees eliminate these blind spots. Their agility allows them to get a 360-degree view of any object. They can fly under, over, and around massive structures, capturing data from every conceivable angle. This level of comprehensive inspection was simply impossible before. The result is a dramatic reduction in defects, which means less waste, lower costs, and safer, more reliable products for all of us. Think about an airplane wing or a surgical implant. You want the quality control on those to be absolutely flawless. Robo-Bees are making that level of certainty a reality. The benefits go beyond just finding defects. They also massively improve efficiency. A traditional line inspection might require shutting down production. A swarm of Robo-Bees can perform its checks while the line is still running, weaving through the machinery without interrupting the workflow. This means less downtime and higher productivity. If a problem is detected early, it can be fixed before it becomes a major issue, saving both time and money. It's a proactive approach to quality rather than a reactive one. Safety is another huge advantage. Many industrial environments are dangerous. Inspecting a giant chemical vat, A high-voltage electrical grid or the top of a towering press machine can pose significant risks to human workers. Now, instead of sending a person into a hazardous area, you can send a drone. These tiny robots can brave extreme temperatures, toxic fumes, and tight spaces, keeping human inspectors safely on the ground, analyzing the data from a control room. This technology isn't about replacing people. It's about elevating them from dangerous, repetitive tasks to more strategic roles, overseeing the system and making critical decisions. This is all part of a larger trend known as Industry 5.0, where we see a deeper collaboration between humans and smart machines. The goal isn't just automation for automation's sake, but to create systems that are more resilient, sustainable, and human-centric. Robo-Bees are a perfect example of this. They handle the scale and precision that machines are good at, while humans provide the oversight, problem-solving, and ingenuity that only we can offer. The technology is evolving at a breathtaking pace. The next generation of Robo-Bees will feature even more advanced sensors, capable of detecting changes in temperature, acoustic vibrations, or even chemical composition in the air. Their swarm algorithms are becoming more sophisticated, allowing them to adapt to unforeseen changes in the factory environment on the fly. Imagine a swarm that not only inspects for defects, but also monitors machine health, predicting when a part might fail before it ever breaks down. This is predictive maintenance on a whole new level. From automotive giants to aerospace manufacturers, companies are beginning to adopt this technology to gain a competitive edge. The ability to guarantee near-perfect quality at an unprecedented scale is reshaping entire industries. As factories become smarter and more connected, swarms of these autonomous inspectors will become the central nervous system of production, ensuring everything operates flawlessly. The silent revolution we spoke of at the beginning is getting louder. Robo-Bees are moving from the lab to the factory floor, and their impact will be felt far beyond the factory walls. They represent a fundamental shift in how we think about quality, efficiency, and safety in the modern industrial world. The era of autonomous inspection is here, and it's being led by these tiny, tireless, and incredibly intelligent swarms. Thanks for joining us on this deep dive into the world of Robo-Bees. If you're fascinated by the technologies shaping our future, make sure you subscribe to Process Protocol. We have more cinematic explorations of manufacturing, automation, and global industry coming your way. See you in the next one.